We will introduce how to write the basic PyTorch neural network programs. We will introduce how to import the required modules and how to load the data set. And then we will introduce how to define models and define the training loop and do the evaluation. So in the first part of our video, we will focus on how to data the data set. And before we introduce the how to implement the data set, we will introduce some required modules for the deep learning program. The first one is the touch.nn. The touch.nn is the neural network building blocks which contain the CNN, RNN, activation function, and those functions. The next one is the variable inside the auto-grade modules of the PyTorch that define actually the auto-grade is an implementation of the auto differentiation of the PyTorch. So for the variable program here, this function will be using in the training loop. We will introduce it later. And the matplotlib function is using to draw the pictures on the screen. And the touch vision, this is the in these modules we define the data set and the data loader for the computer vision the program. And there's other things like the touch test and touch audio here for the NLP task and for the audio task. So there are two ways to load the data set. First one is using the touch vision. The other one is to implement a user-defined data set. We will introduce both of them in the next few slides. And for the in the touch visions, it includes a lot of well-known data sets such as the NIST or ImageNet or CIFAR. And by using the touch vision, it is quite easy. We're just using the dataset modules and specify the name of your data you want to load. So for example, it's NIST here. We can load the data set inside this directory, so that if the data is not available in this directory, the data loader will load the data from the web for you automatically if the download is equal to true. And we can specify some transform function here. For the data loader, but it will be using to load the data in batch. So the data set in the previous slide, we can access the data one by one. But in the typical training loop, we will need to get those data in batch, and we hope that to have some manipulation of the data in advance. For example, we want to change the order. So if the shuffle is true, it will change the order of the image. And we want to load the data in multiple thread features so that we can use more CPU to load the data so that the CPU can provide the data quick enough for the GPU to consume it. Since the performance of GPU is very fast today, so typically we need to using a lot of CPU to prepare data so that the GPU will not be idle to wait for the data from the CPU. Okay, so we can specify the data set by using data set argument, and we can specify the batch size to be the size of the mini batch. And we can specify if we want to render the order of the image, and then we can specify the number of threads to read the sample in the CPU. Okay, this is the whole data pipeline. The data will be defined in the data set, but we will define a data loader which can read the data from the data set and do some transformation, then return all the data to in a bench to the training loop. So before we go into the training loop, we can make a summary for the purpose of the dataset and data loader. So for the beginner of a deep learning program, you might have some confusion between the dataset and the data loader. So the dataset is using to fetch the data from the data source. So typically we will define where the data is and how many data we have in the dataset and what's the transformation we want to implement for the dataset. And then after the data is read from the file system or any other data sources, we need to transform it to be a data which is usable by the training loop. So later, first we need to implement data augmentation to make the data more for example to cut and cover the data or to resize the data to the resolution required by the model, or we need to add some noise or some small changes to the image so that the model will be more robust. Okay, so here is a lot of typical data augmentation here, and actually there's a lot more. We can implement a lot of different data augmentation to so for the training so that the model will be more robust. Okay, so in the data so that in the data loader, it will try to split the input data into a couple of batches and using multiple threads to read the data from the data source and transfer the sample into useful form for the training loop. Okay, so here is the way we using the data loader. And in this code, we're using the enumerator pattern or iterator pattern of the Python. So if you are not familiar with the iterator pattern of the Python, please read the article, the link in the top of the slide to be more familiar with it. And we will introduce it a little bit about it later. But I encourage all of you to read this argument if you are not familiar with the emulator in the Python. So this statement will actually get a batch of the samples from the data set and then save it in the batch X and the batch Y here. And the X is actually the input, Y is the output label. X is input image for the computer vision task, computer vision data set. And we will using the variable modules here to convert the tensors into parameters for the models. So after we convert it into the variable objects, the deep learning models can use this data for the training. So we must be very careful about that. This is not a tensor, it's a variable. The deep learning framework will not be able to handle the tensor directly, since the tensor for the deep learning framework is just a constant. So if we want to let those number to be something which can be modified by the deep learning framework, we need to make it as a variable instead of a tensor here. Okay, so this is what we call the emulator, the iterator pattern here. So what is this will be a little bit confused for people who are not familiar with the iterator patterns. So emulator will add a counter into the iterator and return an emulators so that we can we can keep track of the progress of the image we have used. For example, we will return the step here. So if we write the program in this way, the step will be index of the data set. So for example, step will be if we are in the batch of the base size is 16. So step will start from 0 and 16 and 32 and so on. And in each batch, we will save 16 image and 16 label in those two the variables, so that we can convert it into a variables for the training loop later. So if you still have no idea what it is, we can make it more simple here. So for example, if we want to go through the whole data set, we need to typically write a program like this. So the I is from 0 to the size of the training data, and we can access the objects in the data set by using this way, by using the array and the syntax to access the data. But the performance of this one will not be very good, since it will not be it will be whenever we access this, you will be using one thread to read the data. So we're using the single thread to read the data one by one, so the performance will be very good. By using the iterator pattern here, the data will be read in different workers, so that we can do the same thing as the loop here. But since the data is read in batch, the performance will be better, since it will use multiple CPU to do the job. So in a deep learning program, we will always using this pattern to read the data set. So after we read the data set, do we need to implement a data loader? No, we do not need to implement a data loader by ourselves typically. But sometimes we do need to do that. So we will try to introduce both ways to do the job. Okay, so how should we implement a custom data set? So since you need to understand what's done in the data set. So in the data set, we need to know where the data is stored, where the data is available. So it could be in a folder, or it could be in a zip file, or it could be in a data set, or in a spatial file system. And then we need to know the format of the label. The different set will have a different way to specify the label in addition to the image. For example, the label might be stored as part of the file name. So in this case, we need to pass the file name to get the label. We will using an example later to introduce how to do this. Or now the label could be in a print text file, so we need to pass the format of a print text file to get the label for each image. Or it could be in an Excel file, such as a CSV file, so that we need to pass the CSV file to get the label. Or it could be just a database, so we need to then read the label from the dataset. So here is the example for the custom image dataset. So we have a label file, we have image directory, So that in the constructor we just read the file from the annotation file, which is a CSV file. We're using the Panda module to do the job to read the data, and then we store where the image is stored here, and then we define a length function to return the length of the available samples in the data set. In here, we're just using the number of the labels, since each image should have labels here. And then we can define a get item functions to read the data. So in the get function, just read the specify the index of the image, and we just using this IDS to get the file name. For inside this CSV file, there are two columns. The first column is the file name, and the second column is the label. So we just read the file name and get the full image path, and then we read the image data, and then we read the label from the second column of the CSV file. So we can just return these two to the caller. But typically for the computer vision task, we need to do some data augmentations, so that this is why we have two arguments here, the transform and the target transform. So if we need to do some data augmentation for the image, the input image, we need to define the transform arguments, and then we can use the transform to transfer the image to the format we want. We can implement any kind of the data augmentation here. And if the target is an image as well, for example, for a segmentation task, the label is actually another image. For example, if we have an object, and the label image might be an object mask, so you will a picture which is the value is one in the location with the object. So that in this case, we need to do the data augmentation for label as well. If we do some data augmentation such as a resize or cut and crop, in this size you will actually change the resolution of the input image, so that we need to change the resolution of the label as well by using the same data augmentation. Okay, so that after those transformation, we can just return the image and label back to the caller, which will be actually the enumerator here. So that we need to know that the number of the variable in here should match the number of items returned by the data loader. Also defined in the data set. So that we need to careful if we have more than one label, or if we have no label for some situations, we need to adjust the number of arguments here to make sure the data will be read correctly. Okay, so now we can define all three functions for a data set, custom data set. So after we define those three items, we can just using the predefined data loader in the PyTorch to read the data. Okay. So the next example is actually to implement a custom data set for the Chinese handwritten graphs dataset. So this is a dataset with more than 100,000 graphs in the data set, so that we can use it to train a handwritten the recognizer for the to implement the Chinese words. Okay, so in this data set, each file name each sample will look like this. So we can just get the base file name here in the receptacle here, and then we split the base file name into two parts by using the underscore. Then we can use the first element in the array as the label. Okay, so although this is in Chinese, but it doesn't really care about it. It just think, oh, this is just one word in any language. It could be in that case. You don't really need to worry about this. This is just is a number. You can think in this way. Okay, so for the custom data set, we can implement. Its implementation is quite simple. So that we have constructors init, so they will just save the file list. And for the init, since this is a file list, we just return the number of the file list to be the number of samples in the data set. And then we can implement a get index function. We just get the files name from the files array here, and then we can open it, read it, so it will become our image objects. And then we'll get a label by using this function. So we just using split and get the last element, which will be the base file name of the image file. And then we split the image file by using underscore, and get the first element. It will be the label of the image. So that we can just return those two labels back to the caller. So now, so you can see that implement a custom data set is quite easy. So in the first exercise, we will ask you to write a custom data set, and in the exercise notebook, we will provide you some test program which will test the function of your custom data set. So you need to make sure to implement a custom data set which will return exactly the same as what we have in the notebook. Okay, so that's all for the dataset implementations. In the next video, we will start to introduce the training loop of neural network programs.